In this lesson, we're going to briefly look at how to determine the x-intercepts of the graph of a quadratic equation. So let's take a look at a couple of examples. X-intercepts of a parabola can sometimes be called the roots of the quadratic function. Okay, and the roots of the quadratic function, as we said, are the x-intercepts. So if you look down at the first parabola, let's identify the roots or the x-intercepts. In this particular parabola, you see two x-intercepts, one of them at -4, 0, and the other at -2, 0. And these are the solutions when you solve a quadratic equation. Sometimes we also call them the zeros of the function because the y values of any point on the x-axis is 0. Now in this particular situation, there are two x-intercepts. Let's take a look at some other possible scenarios. For this parabola, notice there's only one x-intercept. So we say there's only one solution for this particular quadratic equation. In this case, it's right at the origin, which is at 0, 0. So far we've looked at one that has two x-intercepts, or two solutions, and this one has one solution. Now let's take a look at what happens if there's no solutions, which means no x-intercept. In this last graph, you can see that the parabola is not touching the x-axis at all. So we say it has no x-intercepts or roots or no zeros. Doesn't mean the graph does not exist. It simply means it will never touch the x-axis. If you look at these three graphs, we're going to identify the x-intercepts. So not the vertex, but the x-intercepts. So we're going to look and see where the parabola is touching the x-axis. Then we're going to actually write the ordered pairs for those points. So in this first graph, if you look at the parabola, you can see the 2 points where it's touching the x-axis. This first point to the left, if we identify the ordered pair, we would put 1, 0. So that's one of the x-intercepts. The second x-intercept is located at 5, 0. In the second graph, notice when you look at the parabola that it never touches the x-axis. So obviously we cannot write a point, so in this case we'll just write none, which means there are no x-intercepts. In the third graph, notice that the graph only touches the x-axis at the vertex. In this case, there's just one x-intercept, so we're only going to write one ordered pair, which would be -4, 0. So again, those are the three different scenarios when it comes to the x-intercepts. Now let's look at a couple other situations when you know the vertex and you know one x-intercept, how you might determine the other one. In this first graph, we're given a vertex of 1, 4 and one of the x-intercepts. The first thing you need to remember is the vertex cuts the parabola in half. So the left and right side of the parabola are symmetrical. So let's go ahead and graph the vertex, which is at 1, 4. So that's the vertex. Then we'll graph one of the x-intercepts, and we'll do that in blue, and that's at -1, 0. Now, our vertex is going to cut our parabola in half, and it's symmetrical. So basically, our other x-intercept should be equal distance on the right side of that line. So our first blue point is 2 spaces left of the red line. So we want to go 2 spaces right of the red line so that it's symmetrical. That way, when we draw our parabola, it should look equal on both sides. So our missing x-intercept is right here. If we write down that ordered pair, it would be at 3, 0. Let's look at the second example. In the second example, our vertex is at -3, -5. So I'm going to go ahead and graph that point. Then one of our x-intercepts is at -4, 0. So the question is, where would the other x-intercept be if it's supposed to be equal distance from the axis of symmetry? Hopefully you can see that would be one space to the right. And then if we drew our parabola, it should be symmetrical on both sides of our vertex. So our missing x-intercept is going to be at -2, 0. In this last problem, the vertex is 4, 6, which is located right here on the graph, and we have an x-intercept at 0, 0. Let me make that x-intercept blue. So if we draw our axis of symmetry, you can see that the blue dot is 4 spaces to the left of the red line. So we want to go 4 spaces to the right so that our parabola would be symmetrical. And then we need to identify that point, which would be at 8, 0. And that completes the lesson on the x-intercepts of a quadratic equation.